Hi, this is Nancy Priya, CS Department, Perry Institute of Technology. This video is for BE CSE students, second year, 4th semester, 2017 regulation. The topic is from the subject Design and Analysis of Algorithms, Unit 4, Iterative Improvement, and the topic is Maximum Flow Problem. So what do you mean by maximum flow? Maximum flow is a maximum feasible flow between the source and the sink. So over a network, we have a starting point called as source and the destination called as sink. So starting from a source, say for example, I am considering this particular network. This particular graph is a network. The starting point 1 is my source and this 7 node is my sink. So from 1 to 7, there will be a travel, there will be a transmission, and I'm going to find the maximum flow over this particular network. So what do you mean by flow? So flow means the rate at which the material moves through the underlying object. So for example, consider this lines as pipes. So the maximum flow for this pipe is 7. So I may not send any amount of water, say for example, or I can send 1 liter of water, 2 liter of water, 3, 4, 5, 6 and even 7 liters of water over this pipe because the maximum capacity for this pipe is 7. But if I tend to send 10 liters of water over this particular edge, over this particular pipe, it cannot be sent. Why? Because the maximum flow is only 7. So the flow is nothing but the rate at which the material moves through an underlying object, and here the object is I am considering as pipe and the material that I am transmitting is as water, for example. Okay, so there will be something to show the capacity and the flow, right? So that you will be specifying using this representation, flow divided by capacity. So say for example the maximum capacity is 5. So which means that it is a 5 liter pipe. So in a 5 liter pipe, I am tending to send 3 liters of water, say for example. So I'll be writing it as 3 by 5, which means 3/5, which specifies that the capacity of the pipe is 5 and I am sending 3 liters over that particular pipe. So this is 3 by 5, which is flow by capacity. So now they'll be giving you a directed a graph, a directed weighted graph, and the weights over the graph specifies the capacities and the direction specifies the flow from which node to which node the transmission has actually happened. So in our computer science, we can consider it as a network and the transmission of packets from one node to the other node. Okay, so to find the maximum flow, you are supposed to form a table with 2 columns, path and flow. Okay, so this is your network and this is your maximum flow calculation with path and flow. Okay, first you can consider any path from source to sink. It is not guaranteed that only this particular path you can take. It is your wish. You can take any path from source to sink for your calculation. Say for example, I am going to take a path 1 to 2, 2 to 5 and 5 to 7 to reach my destination. So 1 to 2, 2 to 5 and 5 to 10. So I am choosing this path. Okay, so to find the maximum flow in this particular path, you are supposed to find the minimum capacity over this path. So the capacity in the sense the edges, the weights over the edges. So what is here? It is 7, it is 5 here and it is 10 here. So among these three, 7, 5 and 10, the minimum capacity is 5 and that will be the maximum flow for this particular path. So which means that I can even take 7 liters over this pipe for the transmission, but when I come to this point, this pipe only can hold 5 liters. If I tend to send 7 liters here, it cannot send. So 7 liters cannot be sent here. So if that is not a case, so here also you cannot, even 7 liters can be sent through this pipe, whereas this particular transmission will not allow you to send 7 liters. So we have to check the minimum among these three, among the flow. So among the flow, 5 is minimum, therefore I am going to take 5 liters to transmit from source to destination, which means 5 packets, for example, from source to destination. So the maximum flow for this path is 5. Hope you are clear. So now the next step that you are going to do is, once you find the maximum flow, you are supposed to reduce it from the original graph given. See, you have 7 right here, okay? So we have sent 5 liters through this path, so the remaining will be only 2 that I am going to write it here. This shows flow divided by capacity. Flow divided by capacity. Okay, so here 5 is the total capacity, so I have sent 5 across the path, so the balance will be 0. And when I come to here, 10 is the overall capacity, and I have sent 5 over there, so the remaining will be 5. Okay, now look at this carefully. We have still 2 packets in this path, right? Whereas to send in this path, we don't have anything to send by this path. Why? Because it becomes 0 here. The pipe is not available for the transmission anymore. Therefore, this path cannot be chosen for your future transmission. Okay. Now, check any other path that are available from source to destination. So, from 1, you can go to 2 because you have 2 available. So, 1 to 2, 2 to 4, 4 to 3, 4 to 5 and 5 to 7 is one more path which is available. So 1 to 2, we cannot go by this path, therefore I will go by this path, 1 to 4, 2 to 4 and 4 to 5 and 5 to 7. So the path is 1 to 2, 2 to 4, 4 to 5 and 5 to 7. Okay. So what is my maximum flow here? Now we have to check the minimum capacity among the path. So this path contain only 2, not 7. Why? Because we have passed 5 already. So only 2 is remaining. So you have to consider only 2 here. So this path contain 2 capacity, and this path 3, and this path 3, and this path you have to consider 5. Okay. Why? Because 5 has been already sent. So only 5. So 2, 3, 3 and 5, right? So which is minimum? 2 is minimum. So the maximum flow among this path is 2. So what happens now? This 2 becomes 0. Why? Because we have sent it. Now here I will be writing 1. Why? Because in 3 I have sent 2. 1 is my remaining thing. And similarly in 3, 2 I have sent, the remaining will be 1. Similarly in 5, 2 I have sent, therefore the remaining is 3. Okay. Now look at this 1 to 2. 1 to 2 is now not available. Why? Because it has become 0 now. 0 divided by 7 now. So we cannot use this path for any more transition. So the starting source node had only 2 ways possible, 1 to 2 and 1 to 3. This part is this is called as blocked. If it reaches 0, no more transmission possible, in the sense it is, the path is said to be blocked. So 1 to 2 is completely blocked. Therefore the only possible solution is way to move is 1 to 3. So 1 to 3, 3 to 6 and 6 to 7. So that is my next path that is available. So 1 to 3, 3 to 6, 6 to 7. Okay, what is the maximum flow? We have to see the minimum capacity. So 1 to 3 is 10, this is 7 and this is 4. The minimum is 4, therefore I am going to take 4 as my maximum flow. Okay, so 4 has been sent now. So the remaining is 6, 4 has been sent, the remaining is 3, 4 has been sent, so the remaining is 0. So as you know already, 0 by 4 in the sense no more transmissions applicable for this path, therefore this path becomes blocked path. Okay. Now let's see any other path that are possible for the transmission. So still this path is available, it is alive, right? So we can choose it. So 1 to 3, 3 to 4, okay, because this path is dead, so we cannot use this path now. So 1 to 3, 3 to 4, 4 to 5 and 5 to 7 is one more path which are available. So I am going to choose this path now, which means 1 to 1 to 3, 3 to 4, 4 to 5 and 5 to 7. 1 to 3, 3 to 4, 4 to 5 and 5 to 7. So we are going to see the minimum capacity there. So this has 6, this has 2, this has only 1 and this has 3. So the minimum among this is 1, therefore the maximum flow will be 1. So the maximum flow will be 1. So once it becomes 1 there, what we will be doing? We will be reducing it, right? So 6 becomes 5 here. In 2 I will be reducing 1, and here I had only 1, I have passed it, so it becomes 0 here, and in 3 I have passed 1, therefore it becomes 2. Okay. So since it becomes 0 by 3, that path becomes blocked now. So this path is said to be blocked. Now look at the graph. Any other path that are alive to reach the destination. So I can choose this path, I think, and here if I come here I cannot reach. If I go by that way I cannot reach. Why? Because it is blocked. By this point it is blocked. So I cannot reach any position through, I cannot reach the destination through any path. Therefore I have come to an end here. So what I am going to do is I am going to calculate the total value of flow that I have found. So 5 plus 2 is 7, 8, 8 plus 4 is 12. So the maximum flow for the network is 12. So this is how we find the maximum flow for the given network. Thank you.